Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Mohammed Najib and I am an electrical system engineering, and in this slide I will present about three-phase system, and this presentation is to present in details the report we have done. So in the beginning I will start to introduce what is a three-phase system and what is the objectives of three-phase system, and I will cover also about delta and Y connection, and I will explain how to design a circuit by using BSIM, and we'll discuss about the results of the circuit we have designed by BSIM in the project and in the report project, and we will talk about the conclusion. So my name is Mohammed Najib and I'm in electrical system engineering. Bismillah, let's start. So in the beginning, Bismillah, the introduction about three-phase system. Three-phase electrical power is common method of alternating current electrical power generation, transmission, and distribution. The system is a type of polyphase system and is the most common method used by electrical grids worldwide to transfer power. Three-phase system is also used to power large motors and other heavy loads. In general, three-phase systems are preferred over single-phase system for the transmission of power for many reasons, including the following: A. Thinner conductors can be used to transmit the same KVL at the same voltage, which should use the amount of copper required, typically about 25% less, and in turn reduces construction and maintenance costs. B. The lighter lines are easier to install and the supporting structures can be less massive and farther apart, and their three-phase equipment and motors have preferred running and starting characteristics compared to single-phase system because of a more even flow of power to the transducer than can be delivered with a single-phase supply, and in general most larger motors are three-phase because the motors are initially self-starting and do not require a special design or additional starting circuit. So the objectives of three-phase system is the ability to evaluate parameters of three-phase system, to measure the sequence and the magnetizing impedance of a three-phase transfer, be able to calculate the voltages and currents for three-phase Y and delta connected generator and load, understand the significance of the phase sequence for the generated voltages of a three-phase Y connected or delta connected generator, understand how to calculate the real, reactive and apparent power to all the elements of a Y or delta connected load and be able to measure the power to the load. Become familiar with the operation of a three-phase generator and the magnitude and phase relation connection, the three-phase voltages. So now let's go to talk to have some information about Y connection and delta connection. So it is the relation between line and phase value in Y connection. We know that the voltages and currents in a given phase, this given phase, are called the phase quantities. The voltages between line, this the line, and currents in the lines, the voltages between lines and currents in the lines connected to the generators are called line quantities. So the line voltage we call EL. We have line voltage here and line voltage in this phase and in this phase. EAB, we see it like a circle. From here, A to B, this one, from B to C, from C to A. And the phase voltage in other N, this one phase voltage, from the point to the natural point. Sorry, from the point A to the natural point, EAN, and from B to A natural point, and from C to natural point. So phase sequence, Y connected generator, phase sequence in Y connected generator. So we have two types, positive and negative phase sequence. The phase voltage in phasor, this is the formulas, and line voltage, this same. The difference between negative and positive, how to read. In positive you will go like A, B, C. In negative you will go other opposite side, A, C, B. So this is about Y connection. And in delta connection, the relation between line and phase value in the delta connection, we have the phase voltage the same, we have explained before in Y connection. So EAB, where it's EAB, this EAB, like this, and this EBC, ECA, okay. Or we can see ABC, EABC, or EBC, or EAC, never mind. So the phase voltage in this generator are given by these, all the formulas, sorry. And the line to line voltage between any two lines will be the same as the voltage in the corresponding phase. So okay, the line, the current, the voltage in line is the same the voltage in phase. Okay, unlike the line current for the Y connected generator, the line current for the delta connected system is not equal to the phase current. The relationship between the two can be found by applying Kirchhoff current law here at one of the nodes and solving for the line current in terms of the phase current. That is, at node A, we can say this node A. So we'll make KCL, this coming in and this coming out. So we'll say this coming out, I supposed to be first IAA equal to, no wait, okay, this is the formula. I can't explain. I have to take a paper to explain. Never mind. Okay. And yeah. Okay. This a formula or this one? Never mind. ABA. Yeah, this coming in equal to what's coming out. This one ABA coming in and A small coming out and IAC is coming out. So we'll get this formula. So let's go. Never mind. So PSIM is an application to design a circuit like this, what we have done already in the report. And in the report we have designed a Y-to-Y connected circuit, and we already find. Okay, let's explain how to design circuit, how to use BSIM to design circuit. First we have to design a three-phase circuit like this. We have three to four connection, Y to Y, Y to delta, and delta to Y, and delta to delta. Okay, and but this one I have already. This one I have already. We have already make it in design it in the report project, which is this one. It's Y to Y connected. So in step 2, I find that line current and voltage by using the formula. This formula, wait. Okay, this my little project report. By using these formulas, then we will get the value in waveform. And the same we calculate in second step also the value of line voltage, well, by using the formula, by using these formulas. And then in step 3 we calculate the power by using this formula, B total equal to BA plus B2, which BA we have already calculated and B2 we have already calculated in this formula and in this formula. So yeah, that's all about BSIM. So now I will discuss with you what I have done in this experiment, in this design circuit. So the values of line and phase voltage in experiments, it's the same. This is because in the first circuit we used a fixed power supply. In this phase circuit we use a fixed power supply, and in the second circuit we use a variable power supply. Okay, the value of load voltage and load currents are approximately equal because the connection is balanced. It is also approximately equal to square root 3. The ratio of the average line current to the average phase current is approximately equal to square root 3. This is to prove that three-phase delta connected resistive load is to show the value of line current is square root 3 generator to the phase current. So to discuss about the circuit, we have used delta to the Y to Y connected. We used 3 voltage in the first circuit with resistors, and here the same as we explained in here. As we explained in here, we used a fixed power for the first circuit supply, and second circuit we used a variable power supply. Okay, So for conclusion, we have distinguishing between line and phase voltage in Y to Y connected as circuits, and verify the circuit calculation for measured parameters in balanced resistive load. The three-phase. So this, the first point is what I have done in the my report project. That's the conclusion about it. And this conclusion is about three-phase system and a common information about three-phase system. So three-phase AC system are considered as a balanced circuit made up of a balanced three-phase source, a balanced line, and a balanced three-phase load. The star to delta, or delta to star, which is, I call it Y to Y, or star to Y, or Y, or delta, what? The star to delta is the same, the Y to delta, or delta to star is the same, delta to Y. Okay. Is required in three-phase AC system to simplify the circuits, and is their analysis. If a three-phase supply or a three-phase loads is contact in delayed delta, it can be transformed into an equivalent star contact supply or load. After the analysis, the results are converted back into their original delta equivalent. So that's all for this presentation, and this presentation was about the report project. And in the beginning I just explained about three-phase system in general, and I give common information about delta and Y connection, and I explain a little bit about how to use BSIM and how to design a circuit by using it. And yeah, that's all, and discuss with you about the long report and about the circuit I have designed. And I discussed about, no, I already finished this. I got to conclusion, and I end this presentation in here. So thank you so much, and see you.